Okay, we are live. Um, Hello, everyone who's out there checking out the live stream at the moment. I have a feeling more people are probably going to be viewing this as a video than as a live stream, but that's totally fine. Um, Today we're going to be talking a bit about the second assignment, which has just been released. I think it was an hour ago, or even less than an hour ago. So it's really fresh, hot off the press. So I thought it'd probably be important for me to start talking about the assignment as if no one knows anything about it yet. So rather than launching into the specific techniques and everything that everyone's been working on, we'll think about well, because I assume no one's working on it yet, unless someone's like super fast and they've hopped in and they've already started in the last sort of half an hour or so. Um, so what I thought we'd start by doing is looking at the spec itself, having a chat about how the bits and pieces of the spec are likely to fit together, and what kind of things you're going to want to do to get started. Should also say, and I'm going to talk about this in lectures anyway, and in tutorials and stuff this week, that we're we're going to sort of give everyone a whole lot of support in the ramp up to this assignment. So like it's nearly the entire week of the course is based around the assignment. I mean, mainly because the assignment's based around exactly what we want to teach you, so it all just obviously links in really closely. So what we're going to do is I'll show you the spec today. If there's any particular part of the spec that people are interested in me going over in detail, now's great because you can just poke me in the live chat. I've got the live chat up on my other monitor over here. Say hi if you're there. I know I can see a couple of people are already online watching right now, so feel free to say hi. Um, I don't bite, and yeah. And so we'll go through the spec, and then yeah, if there's time, we might actually write some code that will give you some assistance in getting started with the assignment. I mean, we can do that here in the live stream. We're also going to be doing it in lectures, and I'm going to get some of that stuff happening in the tutorials and the labs as well. Apologies, the labs and tutorials haven't actually been released yet. This always sort of happens around assignment release time, where it's like a whole lot of my time and effort ends up going into the assignment, and then the labs sort of just get pushed back by a day or so. But I mean, they'll definitely be ready before you have your labs tomorrow. But I apologize to anyone who was going to try to get to them before the actual scheduled time and just trying to get ahead because I haven't actually finished writing them yet. Having said that, I'm trying to write them so that they're a little bit custom tailored to the assignment, so everything is sort of very focused in this week on what we're doing. Okay, let's hop over to my window here, and I've already got this open, so I open it in advance. Oh, hi Ben, how's it going? um, Oh, I should probably point out. Actually, no, I'll talk about this stuff in lectures. Assignment one is partway through the marking process, and so some of the performance marks are available. There might be an issue with the performance marks. I have I've gotten two emails, and two emails is enough for me to actually think about. So, two emails from different people saying that stage four wasn't being marked entirely correctly. So, we'll investigate that. So, anyone who's been wondering about that, don't worry too much because I've got it from more than one different person now. Like, there actually might be a problem with the auto marking system we used in that case, but we'll look into that. I'll probably say that in lectures because if I want to say stuff like that, I want to actually reach more people. But anyway, let's go back to. I'm going to open my window here. Okay, so this is Castle Defense. Um, Castle Defense is basically my way of trying to sneak a tower defense game into a subject about computing. I mean, like, it's not like tower defense games weren't written by programmers anyway. So, um, what we've got is a what we're calling a realm, which is just a a big space where um, I have my castle, and it's the castle CSE, and it's under attack from enemies. So we haven't really specified what the enemies are. They're just sort of generic enemies. And if anyone's played any tower defense games before, what they usually have is just a set path that enemies walk along. So there's like just generic little enemies, and they're going to walk along this path, and then around the path you can put little towers that will shoot at the enemies. And the aim is to basically try to kill off as many of them as you can before they reach the end of the path. And we've done this in a particular way. We haven't built a map, so it's not like CS Paint where we had a 2D space with a grid and stuff like that. We didn't want to do that because things were going to get really overcomplicated if we added a two-dimensional grid to this. So what we actually have is the space that you're going to be working in is actually a linked list. So obviously, because that's what we've been teaching you, like what we're just ramping up into teaching you now, and what we're going to be working on a fair bit over the next week is how to use linked lists. And linked lists is a really good thing to learn because you learn a little bit about memory management. You learn a little bit about pointers, you learn a little bit about structs. So this is all about us tying together all of the semi-advanced techniques that we've been working on in the second half of Comp 1511. So the way a tower defense game would work, I guess in this case, is we could have a series of locations, and we always have our castle at one end and the lair at the other end. So what we're doing is we're always having a start location for the enemies. I mean, they don't actually have to appear there. If we want to, we can actually make them appear at other locations. But in general, what they're going to do is they're going to start at the lair, and they're going to walk through these locations until they reach the castle. We're not doing any real-time programming. Real-time programming is like stuff that actually works at the same speed as us. So like, if you're walking between one space and another, that would be what we consider real-time. But in Castle Defense, what we're doing instead is having it so that we can actually give a command that goes, okay, now tick time forward, and when time goes forward, the enemies will move from one location to the other. So you notice we've got a few different locations here. The lair and the castle are going to be in every every simulation of castle event. So every time we run it, we're always going to have a lair and a castle, and we're going to add locations in between. So this is actually part of what you're going to be implementing is the program that accepts the instructions to add these locations, um, put things like defensive towers in and stuff, and also add the enemies and tick the time forward so the enemies move from location to location, and also do things like towers will basically shoot at the enemies that are at their location, and enemies can damage the castle if they reach the castle's location. So lots of little things, and I think today what we want to do sort of is just sort of look at the overview of what it is and how it's working, so that you get a decent idea of how the kind of how the game works in a sense, and then we'll look at specific code as we go deeper into it. So the way we're laid out is we have a struct called the realm. The realm is not a linked list or anything like that, but it's a structure that actually has some pointers to the start and the end of the location list. And the location list is a linked list, and so it's got all of these elements in it. What we're going to need to be able to work with this is the ability to add and remove items from a linked list, and quite often we're going to want to be able to uh, like walk along the linked list. We're going to want to be able to go, okay, if we started at the lair and then we followed our next pointers to here, next pointers to here, next pointers to here until we hit the castle, then we know that we've seen all of the elements in the list. So there's obviously going to be some work where we need to like scan through the list. So sometimes we need to scan through the list and find something. Sometimes we need to scan through the list and perform an operation on every item that's in the list. So the basic kind of data structure we're working with is always going to be this. There's a realm and a set of locations. We can get into more detail though, because we actually get enemies as well. So I'll go down. I'm actually I'm not going to talk through all of the text, but I'm going to show you stuff like these diagrams and show you how they're working. So if we have, this is a portion of the linked list of locations. There can be more locations than this, obviously. Well, because this is obviously not complete, because this one here that I'm looking at doesn't have the lair and the castle. So if it doesn't have the lair and the castle, it's not actually a valid realm. But this is just a part of it, and we talk about this second linked list. So every location has a pointer coming off it to a linked list of these enemies. And so I've just made these just but generic kind of fantasy enemy names, goblins and orcs and stuff. I was going to use Batman, but I think we've got a lot of Batman so far, and it actually kind of made no sense that Batman would be coming to destroy our castle, so I didn't go with Batman at this point. Say again. Tom's just letting me know that once you get deep enough into the assignment to start playing around with the auto tests, apparently there are actually Batman jokes in the auto test. So at some point, Batman or someone else might actually be coming after us. I didn't write the auto test. Tom's been writing the auto tests for us. So um, we have this linked list of enemies, and so the enemies are interesting because they aren't as as fixed as the locations are. The locations are going to get sort of put together at the beginning, and then you're going to like run the enemies. And as you do these kind of time steps, the enemies are going to move, and they're going to get attached to different locations. So we're going to get this kind of situation where we have like the structs for the creation of each of the enemies, and then these things can actually be moved as they go around. There's some details here for what's inside the struct. So this one, I think the enemy struct will be reasonably familiar to us because I've actually done a demonstration before about using a struct to represent a character that's in something like a game. I mean, like obviously because I knew this was coming up, so I wanted to do it. So like the things we're doing, like the Ninja Turtles and stuff like that, with the hit points and stuff like that, we have that here in the enemy. So we're going to have a series of enemies in every location, and then these enemies. When we use certain commands, are going to move forward and stuff. And if they're at the location where the tower, then stuff's going to happen. So they're going to interact with the tower in some way. Um, Usually that just means the tower uses up some of the ammo that it has. We're calling it uses because it's not really ammunition because it's sort of like a generic kind of thing. If these towers are magic, then they're using up mana. If they're a cannon tower, then yes, they're using up cannon balls or something like that. But what we did was sort of abstract that away so we didn't have to say specifically what these things were shooting. So what we have is the towers, and as the towers attack the enemies, they use up the amount of uses and capabilities they have. So let's go and have a look at the towers. Um, oh, this looks like a set of binoculars. Sorry, just marveling at my diagram creation. Anyway, here is another partial set of a linked list of locations. Um, all of the structs that are in the linked list of locations are going to be location structs. So I've just labeled these as location structs. The castle and the lair are also location structs. They just have a particular use in that mainly the castle, and the castle has a little bit um, more than a normal location involved. But we will usually be separating our locations into two types. One is a land, and the land is pretty simple. So the land is just it's just a space, you know. So it has space for enemies, in which case there's going to be a pointer to a list of enemies at every location, whether it's a land or a tower. Um, but it's not really going to need any other information. So the here, like we've been naming these after like so there's like you can see where we're going here, right? The towers are named after your lab rooms, so they're the places where you fight off the enemies, like debugging code and things. It's it's a wonderful metaphor. Just roll with it. The other locations around campus, so I had one for Quad, one for Matthews A, and stuff like that. Actually, Matthews A probably should have been the castle, because that's where I reside and I'm the king, just in case you didn't see that at the beginning. And it's also where we all gather together. So that kind of could have been the city or the castle. I missed the chance to do that. Anyway, so what we have is a tower has some other information. So each location has a type. You see these are all caps with underscores, so you may recognize the formatting for that is a hash define. So somewhere in your code there'll be a hash define saying this is type land, this is type tower. They will be mapped to numbers or something like that, but we don't actually really need to care what they're mapped to because we're just always going to be using them as these words. And our program's going to care what numbers they're mapped to, but we're going to care about what words they are, which makes it easier for us to use. So you don't really need me to explain that type tower means this thing's a tower and type land means this thing's a land. So we've got this kind of nice way of doing things. I hope the idea of using hash defines for stuff like this is starting to become a little bit of second nature to you now. Like the fact that you can go, all right, not everything has to have its number value. Sometimes some things can have their name, and their name is their use. So the tower itself has the amount of power that it has. The amount of power is the amount of damage it's going to do. And if you push all the way through, you see we've got like 5 stages here. If you push through stage 5, the power has other things that it can do for one of the things in stage 5 as well. And it has a number of uses. So the number of uses is the number of times the tower can act. So this tower is pretty good because it's doing 5 damage and it can work 20 times. Well, I mean pretty good. I mean good's relative. I could make an enemy that had like 5,000 health in this tower. It would be basically useless. But, you know, we're not going too deep into any game design or balance or anything here. What we're looking at is your ability to use these structures and get them to kind of function in a game-like situation. Okay, so um, yeah, we have the details in each of the structs and whether they're a tower or not. So back up here, each of these locations is going to have that information filled out in some way or another. All right. Um, there's the castle as well, which is the only thing it has that's different from the other locations is the castle has a certain amount of hit points. Um, Interesting thing about this is you get to decide how you're going to track the hit points for the castle. So you could actually put it in the location for the castle, or you could even put it in the realm. There's different options for however you want to do this. The game itself has a sort of a way of running in the terminal where we can just put information in the terminal and then that information goes into actually making the game run. I think this is a good point actually to show you this working. So before we actually start talking about the implementation of the code or anything like that, we have a reference implementation here. So I'll just clear that because we don't need the other stuff that I was looking at. Um, oops, 1511 castle defense. We've gone with the S on defense on most everything, unless I've typed something wrong here and there, just because the standard tower defense genre was invented in the USA, and they tend to use S rather than C for defense. Um, I think. Wait, we're using the C or the S? Oh, we're using C, the language C. Tom made a pun and it's very bad and he's fired now. Especially because the 2 assignments have been made, so we don't need him anymore. Anyone who's in his tude, I apologize. He's been fired. He made a joke that rivaled one of mine, and as I have recently crowned myself king, I will be putting him to the sword. Maybe I'll quarter him. You know when they tie people like each limb to a horse and they just drag them apart until they rip apart? Yeah, maybe I can do that to Tom. Instead of horses, I'll have tutorials. So each tutorial will hold on to a rope out of 4 of the tutes, and then we'll just pull until. Anyway, okay, so this command, 1511 castle defense, let me just also go down to this section on testing, and we have the command here just in case you need to go back to it for the reference implementation. So the reference implementation is like we can't write every single tiny thing in the spec for all the details about what's going on. I mean, we tried, and it took ages, and that's why the assignment only got released today. So I think what's often good is to use the reference implementation every now and then and just say, okay, um, it didn't say really, really precisely exactly the details in these stages about how we needed to do things, but let's have a look at what the reference implementation does. We can just sort of compare what we're doing against that. It's a decent way to do things in this situation. When we're doing things in like a real coding situation or a professional coding situation, you're never actually going to have a reference implementation, because if the reference implementation existed, you wouldn't have to code it. But for at this point, like we're still in first year programming. We're gonna give you exactly what to do, and then you can copy it. And then later on, when you get deeper into program, you can be like, oh, okay, these decisions are up to me. I will make this how I want it. But for the moment, we're gonna run this, and so I'll show you a little bit about how this works. So it says, "Welcome, brave and noble engineer." So you are my engineers, the king's engineers, who are going to defend the realm for me. Um, the realm starts off by having its locations created. And so it's going to I'm going to type in a set of locations now, and those locations are going to go from the lair to the castle in that order. And when I'm finished with locations, I'll have an empty line. So what I might do is, because we're just linking this whole thing to UNSW, I'm going to do the walk from our lecture theatre. So apparently the lecture theatre is the place of greatest danger. Oh wait, they don't have spaces in them, so I'll just say Matthews A. And what's closer to us than Matthews A? Library. Then we've got the giant Scientia building. Um, we have, yeah, let's go for the electrical engineering building. I feel like I should have used underscores, and now it's too late because I said Matthews A without an underscore. Oh well. And then we're gonna go across because we're doing this. I'm gonna go to K17, which is the the building that houses the computing school. So that's where people like me are found. So those locations, and it says when I'm done, enter an empty line. So I'll press enter again to enter that empty line, and it's like, cool, I have created a realm, now I may enter commands. First command that you're going to want to know, and this is the command that you're going to be using most of the time for everything, to just sort of remember how things work, is the question mark. So the question mark command is going to tell us what the other commands are. I should point out that a lot of this stuff here has been written for you in the assignments. We're not doing this massive amount of print and scan and print and scan and stuff like that. What we wanted you to do really is to get into the meat of working with the linked lists. So a lot of the print and scan, a lot of what's in this main.c is actually already done for you. I mentioned main.c. I'll talk about that later, about how the file structure is done for this assignment. It's a little bit like how I was telling you about multi-file projects last week, and this is a multi-file project, so this will be your first chance to play around with a multi-file project and see how it works. So, question mark, enter command. I'll just scroll back up. This shows us help, and so it shows us everything we can do. So we have a help screen. Yes, we just did that here with the question mark, and these other commands that we can use. So Q to quit the program, P prints the current layout of the realm, T creates a tower, and that's going to need some more information about what the tower is. N advances the game state, so you can think of N as like saying next, in a sense. D applies damage. E creates an enemy, and B and F are buffs and effects. Don't worry about them too much yet. So they're like they're stage 4 and 5, which are uh, after we've created a land and towers and we've been able to move stuff, then we can start making towers that do different things, or we can start actually upgrading enemies and towers and stuff like that. So it's kind of like what we're building is a program which is the entire engine behind a tower defense game. So we're going to be implementing, like, this is like, actually having done this in the past, this is what we do as a game programmer. So I don't know if anyone's interested in going to games, but these kinds of engines are the things that we build underneath things. And you can see how we haven't really specified how much damage a tower does, or like how many hit points each enemy has and stuff like that. That stuff is the kind of thing that would come under game design rather than game programming. So it's a slight difference there. Anyway, so let's try out some of these commands and see how they work. I think P is a good one because P is print realm. Yeah, so that's going to print the current layout of the realm. So let's have a look at that and see what it does. Cool. All right. So as I said before, and let's go back here. Where are we? The realm. The sidebar is helpful because we have put a lot of text into this because we know that at every point in the assignment, you might be spending a few hours on like one little bit. So I might just be like, okay, this little bit here, this one page, you might spend a few hours on this. And so we've put as much information into this as we put into like a single lab exercise so you kind of know what you should be doing with it. So don't be afraid, there's a lot of text here, but I think you'll probably be focusing on just small parts of it at a time. Okay, so the realm itself always has a lair, always has a castle, and it has some locations in between. So if we go across here, this is our print command, which just shows us these things. So the lair is there, Matthews A, library, Scientia, Elec K17. So if I scroll back up here, these are the locations that I input originally. So this is what I was saying, which was like, um, uh, this is the land. In the code in the back end of this, it's actually a linked list of locations. Okay, so yeah, there we are. And you can see in here Castle has slightly different information than the others. So the lands don't have any particular information, but the castle has a certain amount of defenses. So the more enemies they get through, the lower these defenses get. And if we really want to when we get to this, actually we'll probably talk about this when we talk about Hall of Fame stuff, which we'll sort of get into as the assignment's been rolling. We don't usually put the challenges in at the very beginning of the assignment because we want to put for us, we put all our time and effort into making sure the accessible part of the assignment is all perfect before we start going on to, like, hey, wouldn't it be cool if we did this? Which is not entirely necessary. Ah, yes, Tom's reminding me Hall of Fame for Assessment 1 will go up at some point. We have a few entries for that. I've emailed a few people back just sort of saying thanks, which is really great. There's some cool little things that people are working on, which is really good to see. I mean, it's always interesting when people take what we kind of thought of as an assignment and had it sort of start and finish, and people go, oh, what if, because that's kind of the power of programming when we think about it, is that you're not really limited by the specification that we give you. The code itself is a tool that can do all kinds of different things, and so it's really nice to be able to say, um, yes, the assignment's finished. Yes, I've already submitted it. But what if I do this? Like, what if I implement something that does something different with the canvas? And one of the cool things about that is, actually, you'll never know about this, but it's cool anyway, is that maybe some of the stuff that you did for Hall of Fame can end up being assignment questions in the future, because we might look at someone's Hall of Fame thing and go, hey, that's really interesting. Like the way they've done it and the way they've laid it out, that could actually be quite a good teaching opportunity for a particular technique. And so it could be, okay, that's going to be stage 4 or 5 in next year's assignment if it's a similar assignment. We don't recycle them that much, but maybe. Anyway, okay, so Hall of Fame stuff, we'll look at that later. So back to our realm here that's been printed out. So we have um, each of these locations in order. So this way, if we want to, if we're using this, we can always just sort of check to make sure the locations have been created. Um, if I want to add a tower, so I'm going to add a defensive tower, and obviously the defensive tower is the giant Tesla ball that's in the middle of the engineering lawn between the electrical engineering building and J17. So I will go have a look at, where is it, T, after location, name, power, uses. So the tower is actually going to insert itself as a new location, and it's going to be after a certain location in this list. So T, and it's going to be after a location. So I'm going to have to give it the name of the location. And so it's between Elec Engine K17, so I'll give it the name elec-eng to say that the tower comes directly after elec-eng. It needs a name, so I'm trying to think of a. Okay, I'm gonna call it Tesla Sphere. So obviously, because that thing, there's no way that thing is just a piece of art. It's obviously a Tesla sphere designed to electrocute enemies. It just so happens that UNSW has never been invaded by orcs. But if UNSW, yeah, if and when UNSW is inevitably invaded by orcs, I'm sure they'll activate the Tesla sphere, and then we'll just electrocute the orcs there, and that will be able to defend that region. Um, what I'm saying may or may not be true. I'm not going to say it's not. Anyway, so it has a name and then it has power and uses. So power is the amount of damage it's going to do. So I'm going to say something like a Tesla sphere. Like it's going to do a reasonable amount of damage, but it's not like a huge damage. So I'm just going to give it a 5. But because it's just running off a power grid, I'm going to say this thing's got heaps of uses. So I'm going to say it'll just zap everything around it like 30 times before it runs out of juice. Okay, and this is the thing about the reference implementation is, yeah, okay, it's done. All I've got now is enter command again. And so this is the kind of thing where it's like, how do we know whether this worked or not? How do we know whether it stored everything correctly? So I'm going to use the print command to just have another look at this. But what you're actually going to be doing in the assignment is not just looking at print commands to see if things are working. We've got a second file that you're going to be working on called the test realm, where you will actually run a different version of the program that tests individual functions like this command here and makes sure they're all working. But for now, we can just look at this. Because actually, I shouldn't go too deep into this, right? Because I'm actually just trying to introduce how it works. So now we have the realm again. So note that the tower now has been inserted into the realm just after elec-eng. So I said tower after elec-eng Tesla sphere. Don't worry too much about the details of all of the specific text here. It's all covered in detail in here. So what we have is the Tesla sphere is saying it has power 5, uses 30, which is great because that's exactly what it said. There's also a code here. You'll get to that when you get deeper into it. If you want to go into stage 5, where this is how the tower can actually change. So at the moment it's N because it's a normal tower. So most of the time we're just not going to worry about it. It's just a normal tower. But later on we can add things to towers to make them have the ability to manipulate the enemies in different ways. Okay, so I've got my lair, I've got my castle, and I've got at least one defensive tower. So the other thing we're going to do is add enemies. So I'm just going to do my question mark again to look at the commands. And I've got here enemy um, after a specific location. I think that's actually at that location rather than after that location because the enemy will be linked to the location that we say here and they have a name and a certain hit points. So I said that in a possible future, may or may not happen, UNSW could get attacked by orcs. Obviously, if UNSW was going to get attacked by orcs, they would start at the lair. I don't know where the lair is. I'm going to assume, considering the direction of movement here, the lair must be the Clancy Auditorium, because that's the next thing in that direction from the library to Matthews up further upper campus there. But anyway, what we're going to do is create an orc at the lair, and then have it appear there, and then we'll see what that looks like. So E for enemy, and it's going to be at location lair. I think it's just called lair. Yeah, it's called lair. Yep. Got to make sure I get the names right for these. It's an orc, and it has 10 hit points. Again, I'm not necessarily going to get specific feedback on this command, whether it works or not, but I can figure out whether this is working by, again, printing and seeing what I get. Okay, so now I have this situation here where I have a lair and I have an orc, and the orc is at the lair because it's being printed out just after the lair, and then there's the other locations there, and there's my Tesla sphere ready to attack the orc if and when the orc gets there. I will, oops, yep. look at some other commands that I can do. So at the moment, I'm showing you how the game plays so that you get an idea about what backend you're going to be building. Obviously, what I'm playing now is is not what you're going to get. So we're going to give you some files to start off with, and the files that you start off with have very little functionality in them. So they can't even do this. So they can't even have multiple locations yet. That's something you're going to have to do. You're going to have to build up the link list and stuff like that. But I still wanted to show you what it looks like when it's finished. Okay, so the enemy's there, and the way the game is going to work basically is these two commands, N and D, advance the game state and apply damage. N is going to say next, and next is going to move the enemies along. So it's really actually all that it does, is it just moves the enemies from one location to the next. So they're like time is passing, and the enemies get to move when time passes. Then apply damage says that if the enemies are at a tower, the tower will damage the enemy and use up some of its ammunition or its uses or its mana, whatever you want to call it. Um, and the enemies will lose some of their health. That works also if the enemies manage to reach the castle. The way that we're doing it, and this is the same way they kind of do it, tower defense is like when the enemies reach the castle, the end, they will just basically disappear. So once there's nowhere to go past the castle, so if they move there, then they will just disappear and the castle will lose some health. So it's nearly like the enemies are like, I don't know, some kind of little walking bombs, and if they make it to the end, they just explode on the castle. So, um, let me just print this out again. What we have is our orc is at the lair, and our Tesla sphere is here. So if I use the N command for the next state of the game, we get a little bit of information here. So the enemies have advanced, 0 made it past the castle. So it's just letting us know that at this point, none of the orcs got past the castle. And if I print out again, my orc is now at Matthew's A rather than at the lair. So this is the kind of thing that we're going to be doing. So there is... Actually, I've got a diagram for it here. So we've got a linked list of locations, and at this one shows sort of two steps in time. So one of them is there's a quad location and the enemies were there, and then the N command was done, the advance movement command was done, and then the link list of the goblin and the orc then moves to this location. So what we do is where we had a linked list of enemies here, we now have a linked list of enemies here instead. And what we would do actually is we would move all of the enemies. So the orcs move to Matthew's A, and then I can press N again, and the enemies advance, and I'll print again, and the orcs moved as far as the library. Just to make this interesting, I'm going to add another enemy. Oh, I can't remember the command. If I can't remember the command, question mark's very good. So the enemy is at a certain location. I'm going to add the enemy to the lair again. Um, and it's going to be a goblin this time, because goblins and orcs tend to come together. How much health did my orc have? 10. Alright, so gobos are a little bit runtier than the orcs, and so it's only going to have a health of 5. And so if I print this out again, I'm going to see my goblins here, my orcs here. To make this interesting, I will also have a few goblins rather than just one. So I'm going to add another goblin. I will give him a different name. So we're actually going to make sure these names are never actually going to be the same. So we're making sure that the enemies are unique per their name. So when we're testing our import, we're never going to give you the same name twice. So this one's called Gobbo, and it also has 5 health. If I print that out, I've got the 2 goblins there and the orc. So now, if I press N for next, all of the enemies are going to move 1 step forward. So the enemies advance, and I print this out. The orc has made it to the Scientia. The goblin and the gobbo have made it from the lair to Matthew's A. So they're interrupting my lecture. You must kill them. Okay. I haven't actually used the D command yet because I haven't been in a situation to need it. But the way that a game would be run if we were going to run it is we would actually be running the N and the D and then the N and the D over and over again. So we'd move the enemies, and then we'd calculate whatever fighting was happening, and then we'd move them, calculate whatever fighting was happening. So if I want to, I can just run D. Towers attack the enemies of the realm, 0 were hit, because the only tower I have here is the Tesla Sphere, and there's no enemies at the Tesla Sphere, so the enemies couldn't attack it. So if I want to then advance again, I will move them, and then I'll press D. Towers attack the enemies of the realm, none were hit. So let's look at where we are now. Gobos have made it to the library. The Orc is at Elec-Eng, which means the Orc is just about to reach the location where the Tesla Sphere is. So let's have a look at how this works. I press N, things move. So now the Gobos are at the Scientia, and the Orc is now at the location of the Tesla Sphere. So we can see how the damage is going to happen here. So I'm going to press D and allow damage to happen. Towers attack enemies of the realm, 1 was hit. If I print out now and have a look at the status of the world that we have, one of the uses of the Tesla Sphere has been used up. Oops, sorry, just dropping my things. One thing that I should say is that the way that the towers work is anytime that they fire, they will hit all of the enemies that are there. So they won't, when these gobos get here, they won't actually use up 2 shots. They're just going to use up 1 shot to hit the entire group of gobos. But what we've got is the Tesla Sphere of power 5, reduce the orcs hit points by 5. I'm going to do N again to move things further along. No enemies made it past the castle. The orc is now at K17. The gobos have made it to Elec-Eng. If I press D now, so this would be the cycle of things. No enemies were hit because the tower can't reach any of them. They're in adjacent locations. They're not actually there. I'm going to press N again. No enemies have made it past the castle still, but the state that we're in now is that the 2 gobos are actually at the Tesla Sphere, and the orc is at the castle. So what I'm going to do now is do the damage phase. 2 enemies of the realm were hit. So this tower here has fired because the 2 goblins are there. I'm going to print out how things are right now. So the damage that has happened. Tesla Sphere used up 1 use. So it's 1 use because every time it fires, it just uses up 1 use. Ben's asking, should the uses be decreased even if they don't hit anything? What we've done for this is we've assumed that the tower is not uh, is not dumb enough to fire if nothing's there. So it's actually it's like it's intelligent enough. So if it was a cannon tower, it's actually got soldiers at the cannon, and they're like, we're not going to fire if we can't hit anything. Or if it's like a tower that fires lightning bolts, like they have like little wizards standing up there going, oh, I'm not going to cast a lightning bolt because no one's going to get hit by it. So we've just sort of made a decision to do it like that. So the towers are only going to use up uses if they actually had a reason to use them up. Okay, so what we had previously was 2 gobos with 5 hit points each at a tower with power 5. So the tower uses up 1 use to fire a shot. The shot does 5 damage to everything that's at its location. So both of those gobos were removed there. When I say removed there, you can see we are going to talk about this in lectures, but we're obviously going to be removing these goblins from the linked list of enemies and cleaning up the memory that we've allocated for them. So going back to how we'd actually do this in C, that's what we'd actually be doing. So we have our gobos there, and then the tower used up another use, and it destroyed the gobos. The orc here does damage to the castle's defenses based on the number of hit points. Oh, Brick or Block is asking me, what happens if you do 2 D commands in a row? So if we want to, we can do another D command now. I mean, it's not as interesting because there's only 1 orc left. You know what I'll do? I'll just add another enemy. So trick is, right, there could be rules for this game. There could be rules that say N then D, then N then D, then N then D. Those rules are for someone who we would consider to be a game designer to decide. So I could actually make a super power up for this game that says that when we hit a certain point and we use this power up, we use 2Ds for every N. So it's like I slowed down time for the enemies, but I got to keep shooting them. Actually, not perfect because I've got this orc here that might hit me multiple times. But anyway, um, but what we're doing is in the castle defensive program we're making, we're giving people the capability to do things, but we're not actually saying these are the rules on how to do it. I mean, when you think about it, it's a little bit like C. I give you a text editor and I say you can write anything you want in that text editor. And then I say it's up to you to decide what you want out of that. So here's a while loop. You can do anything you want with it. So you can make it run forever so that it doesn't work. In the same way, if I wanted to, I could just press D over and over and over again, and it would just like I think at this point the orc would just take down my castle. So we can definitely look at it. We can definitely try to do it, and you can test things like that. We could say that the sort of ideal way that this game would run is that enemies would only ever appear at the lair, and then after appearing at the lair, they would then walk all the way to the castle if they made it to the castle. And every time they took a step, there would be a damage phase as well. But we don't actually have to follow those rules because we're programming this ourselves for any capability we might want to do. So let me add an enemy to the Tesla sphere, and we'll run multiple damage phases in a row, and you'll see that like the program's quite happy to run multiple damage phases in a row. Like it's okay at doing that. And it's also quite happy for me to add enemies at a place where it really doesn't make any sense for one to just turn up out of nowhere. Or unless something is like burrowed up from the ground underneath the Tesla sphere. Okay, question from Ben. If you've killed an enemy, can you then name a new enemy the same name as the enemy that has died? Yeah. So the only thing that we're sort of guaranteeing is that there's no two enemies in existence at any particular time that have exactly the same name. We did that on purpose because, and we're not saying that you can't do it, because you can actually do it in here if you want to. You can make two enemies with the same name. It's just going to cause problems because we're actually doing things like sorting the lists and stuff. So we have kind of things that are happening where groups of enemies might actually be merged together into a big group of enemies. And what we're saying is, and this is part of the assignment, is you have to keep these in alphabetical order. Um, I'm going to talk about this in lectures as well about how to kind of keep something in alphabetical order. But once we have multiple enemies with the same name, then it becomes a bit confusing to keep them in alphabetical order. But that's only a problem if there's multiple of the same name at the same time. So if it dies and you bring it back and it has the same name, totally fine. You can do that if you want. So let's pop up a couple of enemies at the Tesla sphere. So let's just say um, I don't know how we didn't see it coming, but an ogre turned up at the Tesla sphere, and the ogre's got like 40 hit points. So it's a big monster. Um, I hope I got that command right. I didn't check if the command was right. Let's print that out. Yes, ogre with 40 hit points is at the Tesla sphere. But we've also got some gobos coming back because we cannot get out. Drums in the deep, right? Ogres and gobos. Sorry, Lord of the Rings, you know, the awesome scene, Mines of Moria. Okay, so the ogre comes with goblins. So I'll do what Ben was asking about there. We'll bring back one with the same name, and this should be fine. So the goblin has 5 health. And there's a goblin archer that also has 5 health that turns up there. And okay, so now we have this big group that's just come up out of nowhere. I should bring in a Balrog as well. Anyway, getting overexcited. So what I could do now is instead of moving these, I can if I want to, because like again, it's up to you. You can do anything you want with it. It's your program. I can run another damage phase here. 3 enemies were hit, so the Tesla sphere went off and hit all of these. And let's print out what the results are. Again, the Gobos only had 5 health, so there was nothing they were ever going to be able to do against the Tesla sphere. Note also, this is the way that we're doing it for this, is that um, if the tower fires, it just hits everything that it can hit. So we're kind of thinking of these as like big siege towers that just cause massive explosions, hit multiple enemies at once. So just make it easier for you rather than like counting down multiple users for every single thing that's there. So everything at the Tesla sphere lost 5 health. which means the ogre's now down to 35, and the two gobos that were with it have just been cleaned out entirely because they only had 5 health to start with. Note also that this orc, um, because of the way we're doing things, the orc doesn't actually disappear until it moves past the castle. So the orc is actually hanging out at the castle and it's still doing its hit points worth of damage to the castle. So this would be a point where we'd go, yeah, this doesn't entirely feel right because the rules of the game that I stated at the beginning was that after the thing hit the castle, it was going to go away. But that only works if we actually were going to follow these rules exactly and do N and D in alternating activations like that. So, but that's okay. That's fine. I mean, this still functions um, okay, and it functions in a way that we can use. So we've got the orc, and the orc has 5 hit points, and you can see here the castle defenses were at 95 before, and the orc hit it again. So if we were going to run multiple damage phases like that, this guy's going to hang around, and he's going to keep hurting the castle. Um, so let's now move on again. So I do an N, which is stepping onwards. One made it past the castle, so the enemies advanced, and one made it past the castle. That is our orc who is there now walking away. So the orc has finished what it's done, and it's walked away. So now we've got the ogre's the only thing still attacking the castle now. The Tesla sphere is no longer able to attack it. The castle's lost a certain amount of health from the orc that went past. Um, for starters, that's as much as I think we need to look at for how castle defense works. So that's actually nearly the first 3 stages of the assignment. So when we're looking about at this, like what I've shown you here is actually what is halfway through stage 3? Is that a distinction, Tom? Let's look at the assessment. End of stage 3 is a distinction. So working implementation of stages 1, 2, and 3, readable code, and some testing. So what I've shown you there, the capability to do all this is actually a distinction in the assignment because you think about like what I'm showing you here, it's quite complicated. There's a lot of stuff going on. So the advancement means um, I need to be able to like detach a linked list from one location and attach it to another location, then detach it and attach it. So I've got this group of orcs that's been allocated in memory somewhere, and they're linked to one location, and then they get unlinked from that location, linked to another location, right? There's a lot of thinking that's going to have to go into like how you actually want to do that. And then there's all these things about how to decide who attacks, like whether they attack or not, would be like whether there's enemies, and then also applying the damage and then applying the damage and having to remove enemies when they've been killed and stuff. So there's a lot of trickery going on in there. And there's actually stuff that I haven't even shown you because I haven't shown you how to remove something from the link list. Yeah, don't worry, I've got diagrams. Um, we're actually going to be covering that tomorrow, or doing things like inserting and removing from link lists. So the ability that I had to add this tower just somewhere in the list involves me kind of just shuffling things around and putting the tower in between them. Um, things like, let me go back here, the idea that I can have a set of locations and I can squeeze a new one in between them. So there's going to be a lot of detail in here, and I think what you're probably going to want to do is is be patient with it and go in order from the stages. So again, we've structured this in a way so that you get your marks in stage 1 that get you to a pass. Stage 2, I think, gets you a credit. Stage 3 gets you to a distinction. Like it's in that kind of structured way again. So if you want to, you can put more effort into just making sure the basics are working, and then you build on from there. So stage, um, I have a quick look through the stages now. I'm not going to go into detail of the code, but I'll have a look at the stages. So we've had a look at how the program functions, which is the game here. And then the starter code that you can download. So the starter code has a main.c, which is the interactive program that runs. It has a realm.c, which is where you're going to actually put your own code. A realm.h. The important thing about the main.c and the realm.h, you can't edit those. So you can't make any changes in those files, and you can't submit them. So don't do any work in the files main.c or realm.h. If you do any work in those, it won't count towards the assignment. In fact, it may count against you because we will be using our own main.c and realm.h, the ones we gave you. Those are the ones we're testing you with. So if you make changes in it and you expect those to be reflected further on in the assignment, they won't, right? So you just got to be careful with that. Realm.c is the only one that you can change. Oh, actually, sorry, and test realm as well. Um, Say again, sorry. Oh, right. There's also a setup script as well. Um, what's the setup script doing exactly, Tom? Yeah. I don't think people. Oh, you know what I'm going to do? I'm going to pass the headset to Tom because Tom wrote the setup script. I'll give him a chance to be on stream and he'll explain to you what the setup castle defense script does.
Oh no, can people hear me now? Yeah, of course. As soon as I get the headset, it's fate. Working now? Oh wait, cool. Um, Perfect. So basically, there are four files that we care about, two of which you can change, two of which you can't. If you run the 1511 setup castle defense program on a CSE computer, so either on VLab or in one of the lab computers, it will create a directory for you which contains those four files, two of which are normal files and you can edit them just like you created them yourself. But two of those files, so the main.c and the realm.h, are what we call linked to files that we own. And basically, instead of being a normal file, it's a shortcut. So when you compile the code, it will look just as if it was your own file, but you won't be able to edit it. And if we make any changes to that code, for instance, to fix up a bug or fix up a spelling mistake, it will automatically appear in your directory, so you don't have to worry about re-downloading it. Any questions about that? Yeah, of course. I'll give you back the headset because I'm scared to. Oh.
Alrighty, I'm back. That was our guest appearance with Tom, where you know how at the start of the stream how I dropped stuff off the table. That was actually the cable for my headset, which I like. I think I rolled over it with a chair and pulled it out when I was getting out of the way. Okay. Um. All right. 2 to 5. I think this is a good time to take a break. So we'll take a 5 minute break, and then when we're done with the 5 minute break, I mean, we've got a couple of people who are in chat at the moment and stuff. So feel free during the break if you want to put up any questions you want. We've got 1 hour, so I can do 1 hour worth of code in the second half of this stream, or I can do some explanations of details. I can answer questions, like anything that you want. Um, and if no one has any questions, I might do some some coding on a linked list that is accessed via a struct that has a pointer to the first and last elements of the linked list, and basically I'll do the first stage of this time, not the whole thing, but some parts of it so that you can just sort of see how we might work within these structures. But I'll do it in a simplified format. Only if you want to, like if you have questions that you want to ask the questions, and I'll try to answer those because the that's what these live streams are for, is for me to to actually give you some chance to interact and ask things. So I'll take 5 minutes. So I'll be back at about 5 past 5, and we'll from there we'll go deeper and look at a little bit of code to get started here. All right, we're back. Um, let's have a look at what we have here. Okay, so what I was thinking of doing, I don't necessarily want to do the code that you need to do for the assignment in the live stream because I consider the live stream to be sort of extra content, not necessary content. If I show people how to get started on like stage one of the assignment in the live stream, then it becomes content that everyone has to be a part of. And there's not like, I don't have 500 people watching right now, so I feel like it's a bit unfair. But I'll probably do that in the lecture instead, or I'll put it into the lab for this week. But what I did want to do is show you some of the stuff to do with the testing for this. So first assignment, we hadn't really gotten that deep into doing proper testing yet. So we'd said, yeah, obviously you're going to need to test, but then you could do the first assignment nearly entirely on what the auto tests did. And if you got everything correct with the auto tests, you had a reasonable idea that you've probably got most of the cases that you needed, and it really actually depends on how you're coding it. But you would have gotten a reasonably similar amount of marks from what you saw in the auto tests to what you would get in the final marking. Um, the automated marking is actually already out. I haven't put a public notice up about that, but you can actually look at your marks. But anyway, um, Castle Defense has an add-on to this where some of the marks for the assignment are based on your ability to run automated testing on your code. So what I want to do now is I'm going to run the setup castle defense. I'm going to show you the files and how they work. Because the one thing that I haven't talked about, I showed you how the game works and stuff like that. And you've got a decent idea how to code C now. So you kind of know that you're going to have to write code to make that work. But what I haven't shown you is anything to do with the code that tests whether what you've written works or not. So let me run this 1511 setup castle defense. So I'll just go back to my terminal. I'm just trying to figure out if I click that and it's lagging, or if I didn't click it. Uh, wait, no, it's good. I thought my VLab had slowed down. It had slowed down, but it hadn't stopped. Okay, so I'll find a good directory for this. Did I have? Oh, I have a directory for assignment too. What's in this directory? I think it might be the solution to the assignment, so I have to be very careful what I do on stream. Okay, I am going to delete all the files in this directory in case one of them is the solution to the assignment, and if I publicize that on stream, then that would be very, very bad. Okay. Everyone in the chat's like, no, 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 do it, it's good. Why don't we look in all these files? Okay, so I have an empty folder here, and I'm gonna run the 1511 setup castle defense. Oh, Tom's saying that the best thing to do is to create a folder and then to do this inside the folder. But I'm in my assignment 2 folder here, so I think this should be okay. So I'm going to run 1511 setup castle defense. All right, let's look at this folder. We have a main C and a realm.h. Both of those are in this bold pale blue color. That's actually them signifying that they're not real files. They can be used like they're real files, but they're actually just links to other files. They're like bookmarks to other files. The realm.c and the test realm.c are real files, however. So let's have, sorry, just organizing a couple of things in the background. Let's have a quick look at them. So here's realm.c, and you can see you're supposed to put your information here in the header, and then there's a few comments in here saying what things are and which functions are in which stages. Note, there's heaps of stuff in here saying this is where you need to make stuff, right? So the C files are pretty helpful in that, like, you follow the instructions, then you should have the structure correct for everything if you follow the instructions. Um, it's not perfect though. Like you still have to do some work. Like we're not going to just tell you now write this code here, now write this code here. Like you do actually have to think. Um, there's more information in the realm.h, which we'll now open up. Note this, okay? Very first thing right up the top of it saying do not change this file. So changing this file is going to have no effect. It won't help your assignment in any way. This file is here to tell you what um, what things you need to do. So in the same way that we looked at H files before, the H files have um, declarations of functions without definitions. So it's up to you to make the definitions. So it's like stage one has add location, print realm, and there's some comments here which say this is what you need to do for those functions. These comments are nearly identical to what is in this web page. The information that's in here about how to use how to write the functions. I think that there's probably more information here in the web page, especially because there's diagrams in here that might help you to think about how the memory is structured and stuff like that. Um, however, there's potentially enough information in the H file for you to work from that. And some of the H file actually has details about okay, this returns this and it does this and stuff. So um, you can go back and forth between them. Obviously, like most of the time when we're coding stuff, we have a specification that we're going to use, which is like a whole bunch of design work that myself or someone else has done before I write my program. And then I have my work in here. You may have your own notes that you want to write before you start writing code as well. Just drop in that hint because that's nearly the most important thing to do is to write your notes about what you want to write before you write code because it helps with your problem solving. Okay, the file I wanted to look at that I wanted to show you, which is something that we haven't necessarily done that much before, is the test realm. Okay, so the test realm looks like this. Just for completeness, I'm going to open up everything. So I'm going to open up the main.c as well. Main.c also says don't change this file. It's got a couple of bits and pieces that we're using for input. But one thing that I'm going to point out, which is interesting about these two files, is my main.c has, I mean, you can kind of tell from its name, it has a main function in it. Testrealm.c also has a main function in it. So these two are never intended to be compiled together. Because if I try to compile them both at the same time, um, DCC is going to tell me you got two main functions. I have no idea where to start the program because you got two main functions. So what we're going to do is we're either going to compile with our main. So we're going to compile our realm.c and our main.c and get our interactive version of the program, or we're going to compile our test realm with our realm.c and get our non-interactive version of the program that does our testing for us. So let's do these two compilations here just so that we can see how they work. So just make sure I'm still in the same directory. Yes. Okay, so I'm going to DCC um, realm.c is always going to be in it. Okay, this is going to be a little bit weird, right? Because my realm.c is nearly empty. It's got a whole lot of functions that don't have anything in it. So hopefully it compiles. I'm pretty sure it compiles even without any of that stuff in it, but we're not going to see any of the functionality we saw in the reference implementation. So I'm going to compile my realm.c, and in order to use my interactive thing, I'll have my main.c, and the output file that I'm going to have for this one, this is where I'm going to start to name these so that actually makes sense to me. So I'm going to call this one interactive. So I'm going to have one program called interactive, and then I'm going to have another program called testing. So I compile my main.c as my interactive, and I'm going to compile my other version of the program, testrealm.c, as tests. So if I run my interactive, okay, I'm just going to ls here so you can see what I'm doing. Two programs, one called interactive, one called tests. They're actually different programs because they have a different main function, so they're going to do a completely different thing. I'll show you the test one in a second. I just want to show you the normal one so you can see, okay, this is the way that we could think about it based on what I showed you in the last hour. So interactive, if I run this, I get this familiar thing. Welcome engineer, enter the locations. So I'm just going to go, okay, there's K17, there's Matthews A, Alec Eng. They're not in order anymore. I'm just putting them in. Cool. And now I can enter commands, so I can check what commands are. And this is the point where if I do a print command, it's going to be like, there you go, that's all the printing that we can do. So this is where you see the gaps that you will need to fill. Um, so I'm going to press Q to quit out of this, which is just going to leave the interactive versions. Okay, so that's how the interactive one worked. Um, that is running this main function. So you can see the printfs here, so it makes it pretty obvious which one is running. Describe the realm when you're done and enter an empty line. So that's exactly what we got at the start of the program that we ran. The other one, test realm, is an automated testing system. So what it's actually going to do is it's going to call functions that do tests. So we've got some set up here for you, which shows you the kind of layout that you might want for these things. Basically, what we're going to do is we're just going to call functions that should work, and then we're going to see whether they actually did the right thing or not. If they didn't do the right thing, then our test program is going to pick up on it. So this is our way of saying that um, every time that I make changes to my castle defense program, instead of compiling with the main, I can compile with the test realm and then see whether all these basic things are working or not. And the marks for the test realm function, the test realm file is all based on, can you actually check whether your stuff is working or not? So can you check for yourself whether your things are working or not? Can you actually see, based on calling the functions, whether they've worked? So let's run the tests version and see what it tells us. Castle defense tests, so that was this printf here, testing new realm, checking it's not null, destroying the realm. Testing print realm, this should show an empty realm, it should not crash, destroying the realm. So we've already got a slight problem here in that when I run this test, what I should be seeing after test print realm is that the realm should be printed in some way, but I'm not showing anything there. And so this message here is saying this should show an empty realm, but I'm not seeing it because empty, they're never entirely empty because the realms that we create always have a lair and a castle in it. So since we're not seeing a lair and a castle, then this test is in a sense failing at this point. And also it's like testing add location, adding locations. If we go in here and we see what that thing's doing, it's calling the add location function a few times, first, second, third location, and then saying it should show a realm with 3 extra locations, and it's asking to print the realm. So because we're not seeing anything here, we can tell at this point that our code is not entirely functioning correctly. One of the best things about this is running those tests took me a couple of seconds, right? Like it didn't take me that long. I didn't have to think about what I was doing. And if I want to run those tests again, I just run the tests again. Like if I was to do this manually, look what I'd have to do. I'd go into interactive one and go, okay, new realm, print out the realm. Um, New realm, print out the realm, check that it's empty. Add these locations, check that they're there when I print out. So the situation then is this test that took me a couple of seconds to type in /tests takes a whole lot of the time out of the like exhaustive testing that we need to do to make sure our code is working. So it saves us a lot of time. So all we need to do is write a couple of functions and then run them every time we make changes. And one of the best things about this kind of automated testing is it actually kind of saves you from when you accidentally change things. So there's a lot of the time when we were working on something and then we go, oh, right, new location sometimes has to do this other thing. So we add something to the new location function, and it works because we've added functionality to it and we've tested it that it works. But what we don't usually test is if it still works with all the old input. And so the old input is like this kind of thing. And what we didn't know is that maybe when we made a change, it actually changed the way that it used to work in the basic sense. And because it changed the way that it used to work, what we're getting is errors that we won't test for because we'll only test for the new stuff that we created. So having this kind of thing, which just sort of goes back and says, all right, I'm going to do test whether your add location works. So it tells you what it's doing, it tries to do the thing, and then it tells you what it should be printing out. And then that way you know that later on, say like I do like an add location, which is like add 8 locations at once. Like I tell you to take a linked list and merge it inside a linked list. And we're not doing that, by the way. That's pretty full on. But if I was, then you might change the add location function in some way. And having changed the add location function, you might end up in a really difficult situation where you've accidentally edited the individual location changing, and you didn't realize you did it because you're only testing the big list merge thing, and your head's in a completely other space. And so it's nice to have these tests. It's like just um, having like auto tests all the time, only they're your tests and you wrote them so that you know exactly what they do and you know whether they're working or not. Uh, so it's kind of like we're giving you marks to run these tests, but even if we didn't give you marks to run these tests, you'd be getting marks for them either way. So this is like double marks. Like you get marks because we're actually going to give you marks on whether you're actually running tests or not. But in the long term, it's going to save you time and it's going to make your code more correct, which is going to get you marks in the performance testing as well. So it's sort of a win-win situation to have this kind of testing situation. And we understand that people have not done any automated testing before, so uh, we've actually sort of given you the framework to do it. I should actually point out this keyword assert. So assert comes from a C library called assert. And what it does is it kind of forces any assumptions that we've made about our code to become concrete blocks in whether our code will run or not. So if I say I make a new realm, and if I make a new realm, I'm expecting that realm pointer to not be null. It should be a pointer to a memory location somewhere. Oh, this realm is actually a pointer to a that would be in the realm.h. There'll be a type def in here somewhere. Yeah. So the capital R realm that I'm using is actually a pointer to a realm. Um, so what I'm saying is, if I've made a new realm, it shouldn't be null. So I'm saying I'm assuming that after I create a realm, it's not null. So what I'm doing now with the assert is I'm saying I'm not just assuming, I'm asserting. So asserting is at a stronger level than an assumption. Assumption is like, yeah, it's probably just going to be like that. We're just going to act as if it was like that. But assert is like saying, no, 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 it's going to be like that. And if it's not like that, we're not going to continue. So what assert does is it actually works a little bit like an if statement in that it checks this here and it says, if this is true, then we just keep running. But if whatever is inside the assert is false, the program will just end there. We can actually test whether this is working by me causing some problems with the realm creation. Okay, so I could just change the assert. Tom's saying just change the assert instead of like butchering the code. That's not a bad idea. So let's say, um, just to show you how this works, I was testing to make sure the realm is null, which is definitely not going to happen because the realm, when it gets created, if I go across my realm.c, has a memory allocation. It has a memory allocation, which means it will get a pointer. Having said that, if the realm could be null if it just so happens we run out of memory right at this point that we're trying to use it. So it could be null, but I'm expecting it to not be null. And this assert is going to check if this is null. So this assert's either going to be true or false. And let me show you what happens when an assert is false. So this is just me screwing with it to make it false. So I will compile my test realm again. So this was the one that has the realm.c and the test realm, and it's called tests. I compile this, and I run it again. So this shows you what happens when an assert fails. So I'm running test, I'm running castle to test, testing new realm, checking it's not null. Test realm C, line 41, assertion realm equals null, failed. So line 41, this assert. The beautiful thing about asserts is that when they go off, as such as when they say, we will not continue from here because the assumption that we made about the code is not actually true, they stop the program from running. So here, execution stopped here. Not only do they stop the program from running, they tell you exactly where they were. So when you get an assert that fails like that, you can go into your code and go, this is exactly the last thing that ran. And the last thing that ran was this assert not coming up the way that I assumed it would. And so it's very, very good, right? You can put your assumptions in to your code, and then you'll see if anything goes wrong and those assumptions have not come true. So you can say that I add a location. So after I add a location, there must be this location somewhere. So I can assert that that location must be there after I've added it. Obviously, you have to write more code. I'm just paraphrasing it there. But if we have the assertion there, if at any time I've made a mistake in my code or something like that, and the location was not added properly, so I created it and didn't add it or something, and I can't find it, the assertion will come up as a null, oh, sorry, not as a null. The assertion will come up as false, and then the program will stop and it'll tell me where the problem was. So it'll go, this is the line where the problem was. This is the assert. So you said it was always going to be like this. You told me that this thing was always going to be null, which is the wrong thing to say in this case, but we're just showing the example. But you told me it was always going to be like this, and it is not like this now, so I can't keep running. You told me to not run if things weren't the way they should be, and so this tells me that's where my problem is. This is where I need to look. And it's great to have it in this testing file because when you've got it in this testing file, you know exactly what this function was testing for. It was testing for creating a new realm and then checking it's not null. And you get this line here, and it's like, okay, this is where my problem was. Um, so what it does is like, because like when we write code, we're always going to have errors in it. Like we're human. We write errors into things by accident. We nearly write errors into things on purpose while we're trying to do something else because we forget what the actual question was we're trying to answer, or we get caught up in something that we think is a really interesting thing to do, and we don't realize that we're changing something, and making it not fit what was supposed to happen. So these tests allow us to kind of stay on track. They allow us to every time we run the test realm, it says all your stuff is working, or a big alarm goes off and this assert goes off saying not all your stuff is working. So you can't keep going on your stage 4, stage 5 heinously difficult stuff because your stage 1's not functioning. And if your stage 1's not functioning, your stage 5 can't function. And so there's no point you trying on that while something's broken back in the basics. So this testing is really good for that because we will only test often we'll just test what we're working on. So we'll test the current function we're working on. So I could be halfway through stage 3 and I'm testing stage 3 functions, only I've broken a stage 1 function. And I haven't realized it. Whereas the test realm is just always like if we keep running it, it's always going to go back and test our basics. And so it's just going to uh, keep us with the feeling of safety that if I wrote my tests well enough and I run my tests every time I make big changes in my code, then I can trust that those tests are always going to let me know that things are working the way they should. And I can put very, very low effort into them as well. So if I just compile that again back the way it was and I run it, super low effort. I've tested that all my basics creating of realms and printing realms works. Having said that, this one doesn't work. because it's not displaying a realm and this one doesn't. So these are actually telling me that something's not working because the printouts are not showing me anything. But either way, um, what I get is a super low effort way to try to guarantee that my basics are working. Obviously, you may find times where these tests don't test everything that you need to test. Um, it's the same way as the auto tests and all the lab exercises we've given you. There's no guarantee that they're exactly what you need, um, but they are like a safety net. So I suggest that whenever you add something, like whenever you work on a stage in this assignment, so I could work on stage one. Stage one. Oh no, I'm above it here. Create new realm. No, no, that's not stage one yet. Stay off. The giant comment saying stage one. So we did actually make this. So it was easier to navigate, but I was just looking in the wrong place. So I can have this add location in stage one, and I kind of print out the realm in stage one. And then when I finish those, I will put stuff into test realm. The nice thing that we've done for you here is test realm is already testing all of stage one. So there's nearly nothing that you need to do. I mean, up to you though. This is your test file. So if you think there's more stuff that you want to test, then you can add stuff in here. So when I get into stage two, and I'm going to add a new tower. And so obviously this isn't working because it's like return success. It's like you didn't do anything. This is probably not success. What we'd want to do is actually make sure that that tower exists. So we'd want to put something in test realm here, like another function, which is like test add tower or something. And then we would want to actually add the tower and see whether it worked or not. And then that way from then on, every time I every time I work with adding or removing or doing anything with towers, I can always just come back and run my tests and make sure my basic adding towers is working. So we had a question from from Spam Us. In O2 new enemies 3 invalid stat, why is there a 0 and -1 HP in the auto test output? Okay, so that's one of the specific auto tests. Um, -1 HP should probably not be there in an auto test output. I'm looking at Tom. Tom is nodding. Spam us you. Tom is nodding in a worried way now. So spam us. You may find that that particular auto test will not act like that in the next half hour or so after Tom finds it and gets it to work properly. But thank you very much for pointing that out because it's actually really useful because like like when we make these things, we we try to think of most eventualities, but like honestly, there's only like three of us making this assignment, so the chance that we can think of every possibility is not going to be perfect. So obviously, we built that auto test and just sort of went, yeah, it's probably working, and then it may not be 100% working. So Tom's digging now to find out why it's not working, and that auto test should go away soon. But thank you very much for helping us out there. That's really handy. Um, it's actually really, really super handy to have. Yeah, like Tom just said, 500 people looking over your shoulder. So having this kind of thing, like, we're pair programming and someone's always there to help you with your mistakes. There's nothing better than the scrutiny of 500 people at once to say, these are exactly where your mistakes are and you need to fix them. And I'm glad we got that one really soon because I doubt there's many other people running auto testing yet. So that mistake shouldn't affect too many people because you brought it to us so quickly, which is really cool. Okay, so testing. I don't think there's anything else I wanted to talk about with the testing here other than like, yeah, this is the idea that we can make our own tests and things. And I don't think I want to necessarily start coding stuff in in the realm.c here because I think if I'm going to do any demo coding for people in in this kind of thing, like adding locations and stuff like that. I probably want to do that in a lecture where most more people can see it. Actually, the lectures tomorrow and Wednesday are going to have a whole lot of information about working with linked lists anyway, and I think that should be enough. But does anyone have any other questions about the assignment? Because I do have some time, but I could also wrap up because I do have a lot of tutorial content that I do want to get written for you all before tomorrow because the tutes start tomorrow and I really need to get that done. But if anyone has any questions now before I wrap up, I'm happy to answer them. Otherwise, I might wrap up early because I have covered everything that I wanted to talk about, right? Because we went through the assignment, we looked at how the game runs, we looked at some of the diagrams, so some of the data structures. We talked about how those structures work, um, and then one thing that I thought was quite interesting that we needed to look at was the different compilation for the interactive version, which is in the main.c, and the automated test version, which is in the test realm.c, and how you can use both of those and sort of interchange back and forth between them so that you can get your automated testing going. But I'll just wait for the chat for like a few seconds, see if anyone has any idea. Say again, sorry, Tom. Uh, Tom is spam us. Tom is 100% confirming that that was a bug in our auto test code, and that's now being fixed. So yeah, it's handy to have that. All right, I'll leave it a couple of seconds in case anyone wants to ask any questions because we do have a couple of people here at the moment. So if any of you have any questions left about the assignment, we've got a couple of minutes now to cover things. Otherwise, I might wrap up, but we will. I'm stalling for time now and just watching the questions thing in case anyone has anything to ask. But it looks like everyone's asked their questions already because I think Ben and Brick or Block were both asking a lot of questions while we were demoing, and so I think they got a lot of their information there, which is good. Okay, what I'm going to do is I'm going to wrap it up here, and I'm going to say, oh, actually, before I wrap up, I want to say one thing is about the assignment itself. Um, don't worry if a lot of it is really daunting at this point, because we're actually going to spend a lot of the time and effort in this week's, like obviously because I just spent the whole live stream only talking about the assignment. The lectures are going to have at least an hour dedicated to the assignment itself with other stuff that's just on linked list, which is all exactly what you need to be able to do most of what you need for the assignment. The labs, we're building the tutorial in the lab mostly around working with the assignment as well. So if you're worried at the moment, um, I think take your time until the end of this week and then see what extra resources we've given you and see whether that's useful to you. And if you're still worried after that, come to help sessions. And also ask on Piazza, and we'll give as much help as we can to anyone who's having trouble getting started. All right, let's wrap it up there. Thank you very much for coming, everyone, and good luck in the second assignment.